Today, I'm solving a problem that absolutely no one asked for. I couldn't find any video ideas, so I decided to make this. In this video, we're making an irrigation system controlled by phone over Wi-Fi for this plant. Well, actually, it's not even a plant. I just ripped off from a tree in my garden just to use in this video. So, let's go. We'll use an ESP32, a breadboard, a soil moisture sensor, 4 alkaline batteries, 1.5 volts, some jumper wires, and a switch. Also, we'll use a 5 volts water pump to water the plant, along with the L298N motor driver to control it. Now let's move to the circuit. So first, I set the ESP32 on the breadboard. Then I connect the sensor with its driver. And now I draw a cable from driver's VCC pin to the 3.3 volts on ESP32. Now connect the ground with the ground on ESP32 and A0 pin with a pin 35 on ESP32. I chose this pin because it's one of the pins that works without any problems when communicating with Wi-Fi. So if you're using another model of ESP32, you may check the datasheet of its pins. Now I take my batteries and make the power connections. I connect the ground pin of my power source to one terminal of the switch and another cable which will connect one side to switch terminal and the other side to the ground on ESP32. So I connect the positive side to the 5 volts pin and the ground from the switch I connect to the ground on ESP32. Now I check if it works, and yeah. For now, we are done with the circuit, and now let's move on to the code. First of all, head over to your browser and write Blynk. And then sign up. So write your email address here, accept the cookies, and confirm your email. But I already have an account, so I'll just log in. Now, create new template here and name it plant watering. Hardware ESP32, connection type Wi-Fi. In description, nothing needed. Alright. Now go to the web dashboard, drag this gauge dashboard to the main screen and save. Now data streams, edit, create new data stream, name it soil moisture sensor. Virtual pin 1, integer, make the maximum 100, and save. Now go again to the web dashboard and get into the gauge settings. And here choose the soil moisture sensor data stream. Save and apply. Alright. Now go to the devices and create new device from template. Choose the plant watering template and create. Alright, so we are all done. Now just copy these credentials and go to the code which I attached in the description of the video. and pass them all here at the top. Now just copy paste the auth token here. Now enter your Wi-Fi information, the name, and the password. And there's nothing left. So you won't need to explain the code. At the top are the Blynk app credentials. Then we included some libraries for Wi-Fi communication and for Blynk. Then we entered the auth token and the Wi-Fi information. Then we defined some variables to read the information from the sensor and convert it from analog signals to range between 0 and 100. Then just print it in the serial monitor. In this line, we send the data to Blynk. In the voice setup, we just begun the serial communication and communication with Blynk app and nothing else. Now, since we are all set up, choose the port and the board from the tools and send the code.
Now pick your phone, head over to the Play Store or App Store on Apple, write Blynk IoT and install this app. After installing it, open and sign in with your account. Now as you see, here appears the device plant watering. Click on it and click to this gear icon plus and here choose gauge. I'll just resize it. Alright, now back, and yeah, again click on the icon, add the soil moisture sensor data stream to the gauge, and yeah, so now I think it's ready. From here, as you can see, it is turned on green, which means the ESP32 is online, and when you turn it off, it will become gray.
Alright guys, I just realized something here. I completely submerge the sensor to the water. It's pure water. And look at the value that ESP32 sends. 46, 48. It's half of 100%. Normally, when we completely immerse the sensor to the water, it should have given a result of 100% and not a half of it. So we should make some changes in the code to fix this problem. So I'll create another variable, integer moisture data, and use the map function to convert the value on moisture final, which is from 0 to 45 actually, and convert it to 0 to 100. So I write here moisture final, comma, 0 to 45 and 0 to 100. Alright. Also replace the moisture final variables with moisture data. Oops, data. And yeah. Now I think it will work without issue.
I'm uploading the code, and at the beginning it's 0. Now I submerge the sensor to the water, and yeah, now we get a more realistic value. So 100, which means the plant is fully watered. Alright guys, I have to cut the video here right now. I apologize for this, but I'm going on a trip, and since there are a lot of people waiting for a new video, I will share this as the first part, and as soon as possible I'll make the second part where we install the water pump and complete the project. So stay tuned and keep following.